I created dedicated water paths. When we create bunds against the slope, all along the bunds we need to plant what is called taproot plants. Now that we have done all these things, landscaping is done, rainwater harvesting points are identified, a flow has been provided. This is what a typical design people will follow. So, this is one of the biggest limitation or the flaw in the irrigation pipeline design. Each elbow makes the water to take 90-degree turn. 4 times the water has to take 90-degree turn and then move out. This definitely creates back pressure on my motor. Friends, when we start designing our farmland, let us say a new farmland or the inherited farmland, couple of things we should look at it and we should avoid as well. One, landscaping. All of us thinks that the land should be flat, square and looks like identical, but nature doesn't likes that. Nature has to retain its own structure. For example, in this farm, in our farm, what you see, there is a terrain. This from the western side, it is going towards the eastern side. Similarly, from the other side also it is coming. It is kind of a V. My farm is like V. So, I have slope like this from west to east and also another slope like this from east to west, and both converges into a center where I build our farm pond, which I will explain there. Our farm gate opens to state PWD road, which connects a place called Koratagere from Dodballapur. This is a state PWD road. You can see a lot of traffic there, and our farm gate directly opens to that road. On either side of the PWD road, or at least specifically at this side, I receive a lot of rainwater. So, we provided these kind of cement pipes to receive this rainwater at the adjacent to my farm main gate, and we build this kind of trenches with bunds. These trenches with bunds will guide the rainwater to flow by reducing its speed and passes through these 2 feet dia cement pipes which I have put and goes down, and the water finally collects at my farm pond. This is very important. How do you make provision to welcome the rainwater to your farm at specific location? If you do not build this trench, if you do not provide this cement pipe structure and given the path up to my farm gate from farm pond, the rainwater would have flooded everywhere in my farm and resulting in soil erosion. So, I planned it in such a way that I welcome the rainwater from the above terrain on specific places. I have 2 such locations identified to welcome the rainwater which comes to my farm from the upper catchment area. So, this rain comes like this, rainwater comes and goes and collects in my farm pond. This is one important thing. Second thing is, as we have slopes like this, we need to create what is called interbunds. We create these bunds against the slope. We have a slope, we create bunds like this. Take the soil from this side and just pack it this side, that become a bund. These bunds helps to check the heavy flow of rainwater and thereby reduce soil erosion and help the water which was stopped there gets percolated down, recharge my subsoil rather than going down. I have created bunds like this at various places. And friends, what I also learnt recently, that when we create bunds against the slope, all along the bunds we need to plant what is called taproot plants. The taproot plants are those plants, they have extended vertical roots and they can go down up to couple of feet. For example, Gliricidia is one such taproot plant which will have a taproot with root system going down as to couple of feet. Now, when you have this kind of taproot plants, what they do, they harvest this rainwater up to a couple of feet inside and do what is called subsoil recharge. If I recharge my subsoil here, thanks to the bund and the taproot plants all along these bunds, this area is completely saturated and I can grow my crops with less water. Very important, we should be able to create bunds against the slope and start planting taproot plants all along the bunds with high density. When you start planting these kind of taproot plants like Gliricidia plus all along the bunds like this, and we let them grow to a certain height, They also act like wind arresters. So a particular, let us assume that there is a 6 feet or a 8 feet plant which is being planted against the natural flow of wind, which will create the wind arrestor feeling to 24 feet 3 times. So I don't have to worry about the effect of high winds hitting my farm and affecting my production plants, because these wind arrestor plants which are planted all along this bund for high density will provide that. So there are multiple benefits of doing bunding against the slope plus planting taproot plants all along the bunds, provides rainwater harvesting, act like a wind arrestor and create microclimate on your farm. Very important thing, we should look at it. Friends, we discussed in a new land what is the nature of the soil. Is it rich with minerals? It has got deposits of potassium and calcium. I have to only do nitrogen fixing in my soil. Then I look at the territory. I looked at where my water comes from outside and higher territory. I created dedicated water paths such that it gets collected into the strategic location, that is called farm pond. Then you also look at creating bunds like this. Across this 8 acres of my farm, we have done n number of bunds like this, a slope, and we planted taproot plants on either side of the bunds. Friends, this is the area where you have to be very cautious. Take a informed decision. If you leave this landscaping and rainwater harvesting structure details to someone else, basically we discuss with that operator, the earth moving equipment operators, and they do not understand, friends. For them, they need to give you a big bill. They does all dosing, push the topsoil there, here to create all those things. As I said, to create this bund, I just take soil from here and put it. I never dose any soil from that side. Means I should not displace topsoil. Very important mantra. We should only enrich, regenerate our topsoil. We should not displace topsoil. This is very, very critical. When you do landscaping, consider this. Now that we have done all these things, landscaping is done, rainwater harvesting points are identified, a flow has been provided for the rainwater to collect in the farm pond, and also an exit path from the excess water collected in the farm pond, which I will show you there. Next part is irrigation. For irrigation system, we create distribution network that we call it as pipeline system or irrigation distribution system. Friends, in this farm, we have a tube well. This tube well goes up to depth of about 450 feet, and I use 3-phase submersible vertical pump, and whose specification is 12 horsepower 18 stage. So 12 HP 18 stage is the specification of my submersible vertical pump, and this water pump discharges the water, and that gets brought down here through 63 mm 2-inch PVC pipeline. So that I call it as main line. My main line comes from my tube well up to this junction. This is my first major junction. In this junction, you can see my main pipeline of 2-inch has come. Now friends, when you do your pipeline system and start using this main line, which is 2-inch dia PVC pipe, we should see to that these pipelines will be drawn from your source of water, that is the tube well, to one end of the extreme corner of your land. In my case, towards the northeastern section, this main line has gone from this place all along to the corner, approximately 480 feet. Now what I did strategically, when I draw this main pipeline, I have introduced these kind of tapping points with a threaded end cap. These tapping points I have introduced all along this, at least 6 to 8 places. In the design itself, if you plan this, draw your main line, feeder line, main line with these kind of tappings. Tomorrow, if you want to take this water from this main line and distribute to this area through subline or feeder lines, this become easy for you to tap. So thereby we use this kind of main line and tapping. My main line has come from the tube well and comes here, and it forks into two. One goes to that side, that covers this section A, which is the southeastern part in my land, approximately 2 acres. This land will be fed by the main line which is passing through this side. the other forking of the main line goes like this towards the northeast. As I said, it goes up to the end about 480 feet. So, when I take this main line and fork it, and I need to decide when the water has to go towards this side or the other side. To do that, we introduce what is called control valve or ball valves. Friends, this is very important. When we introduce control valve, flow control valve or ball valves into our pipeline system, either for a main line or for a sub line or for a feeder line, we have to take some precautions. Generally, people uses this design to introduce valves. So, you assume this is your main line coming from wherever it is, and here we have done the forking, and I need to introduce a ball valve like this, such that whenever I do not want water to go to this section, I can close this, or whenever I want it, I should be opening it. To provide this ball valve control above the earth surface for the operator or for the farm manager to manage, what we do to the main line, which is underground PVC pipeline, let us say about 1.5 feet to 2 feet, depends on what precaution you wanted to take. I will not recommend not more than 1 feet, because we do not till everywhere. So, this is my main line coming from the tube well. Just to accommodate, to introduce this ball valve, what I have done, here I put one 90-degree elbow, raised it to my surface level, just above the surface level, put another 90-degree elbow, then introduce my ball valve control, then it continued like this, then another 90-degree elbow, then goes down to whatever the depth I have done the pipelining system, then continue like this. Friends, this is what the typical design people will follow. There is a flaw in this, there is a disadvantage in this. What is that? As you simply visualize now, the water has to come from here and has to go out here. Just to ensure this, just to put this control, we have done all this structure. One is the cast. Second, water comes and it takes a 90-degree turn, comes to surface level, take another 90-degree turn, and decided by the valve control, then comes into this, take another 90-degree turn, then goes down to the pipeline depth and take another 90-degree turn. We have 1, 2, 3, 4, 4 numbers of elbows or 90 degrees. Now, just each elbow makes the water to take 90-degree turn. 4 times the water has to take 90-degree turn and then move out. This definitely creates back pressure on my motor. The theory suggests that each elbow will put a pressure of 3 feet head height. If my motor is operating at certain head height, every time you introduce a elbow like this, it puts a backward pressure of 3 feet. In this example, 4 into 3, 12 feet of head height of the motor being used to introduce this valve. Friends, on a typical pipeline system like mine, I have major forking junctions like this, about 8 numbers. Now, if I have 8 forking junctions like this and introduce 8 ball control valves, and each junction I will put 4 elbows, I would have introduced it totally 8 4s are 32 elbows. 32 elbows into 3 feet head height, which is more than 100 feet. My motor specification itself is 100 feet head height. Just by putting 8 number of valves like this with these elbows, all my motor specification is used here only. Means I am putting unwanted backward pressure onto my motor. As a result, the motor always operates at stress. Secondly, the water discharge through the system will get affected. You do not get the desired pressure to cover as many plants as you wish on the drip lateral or as much of diameter circular radius with the sprinkler or winkler system. So, this is one of the biggest limitation or the flaw in the irrigation pipeline design, which I have understood on day 1 and I have eliminated this. So, please do not use these kind of designs in your pipeline system. Then you can ask me, Manjunath, then what else we should use? Here is a solution which I have successfully deployed in this farm. So, friends, this is my main line coming, it is coming from one end and it is going to the other end, and this is the section on which I need to switch on my water flow. I put this kind of a T junction. Next to the T junction itself, this is, let us assume this is at the 1.5 feet or 1 feet at the from the surface level. There only I put my ball control valve like this. So, this is the main line which goes from one end to another end. This is the another fork from the main line which feeds a specific section. For that I have introduced this T junction and then extension, and this ball valve is introduced here only. This ball valve decides when the water has to flow to this subsection or this part of the land area or not. Friends, I have successfully installed a valve system to control my water flow without using any bends. In the previous design, I have shown 4 bends are used to accommodate this ball valve. Now I have used 0 bends to install this ball valve. You might ask a question to me, Manjunath, if this are been done and your entire file system is pipeline system is below the earth, how do one operate this? For this I have a solution. What I did, friends, I created wherever those kind of forking and wall interaction happens, I have created this kind of chambers. So my wall remains all along the pipeline there, and my in order to operate that wall, which is at approximately, let us say 1.5 feet to 2 feet, what I did, I created a structure like this. This is simple rod with a T, and at the end I have U. This gets welded. So I use this rod and connect to my ball valve and operate it. Now it is closed. It is opened. See, so easy. So what we have to do, we have to get wall control rods like this. Now in order to protect them, I create this kind of structure or the chamber such that those things never gets damaged. So you can see about 6 or 7 locations I have made like this. Thereby I have reduced more than 30 numbers of elbows. Thereby I have facilitated my submersible motor with less backward pressure on that. My motor now pumps the water at its maximum efficiency, and whatever the water comes from my pipeline goes and discharges to the drip lateral or to the sprinkler system with a rated speed. Thereby I can get more number of plants gets covered through the drip lateral or larger increase in the diameter of my sprinkler irrigation system. This is very, very, very important, which I followed in both my farms, and I suggest this to any of my friends or my clients whom I do consulting on these aspects. Friends, we have created the trench and bund system to receive the rainwater either from the higher terrain next to my farm main gate or from this terrain which collects down to this particular portion. My farm looks like a capital V. I have slope coming from the western side to the center and also the eastern side to the center. So the shape like this will help me to harvest rainwater from this portion of the land as well as that portion of the land, and also have my neighbor where I have a hill kind of small hill kind of a structure. So this also brings in lot of rainwater to me. So this all this water gets consolidated to this area, and when I do this road formation, we have used 2 feet dia cement pipes such that the rainwater which collects here will flow through this 2 feet dia cement pipe and collects on this area. This is my farm pond, friends. The water from the main PWD road main gate all along these trenches, this upper section and this section all get consolidates here and stores in my farm pond. This farm pond we have constructed in the year 2022, and that year during October, November, December we have received very good amount of rain. My farm pond was full for almost those 3 months and overflowing. In the last year, that is 2024, in the fag end, that is October, November, due to Fenegal cyclone effect from Chennai, this pond got filled up almost 3 times and water was flowing almost for 8 to 10 days. Friends, we have designed this farm pond to receive the water, rainwater, store it here and help recharging of my subsoil. We do not collect rainwater here for our irrigation purposes. We collect rainwater here for recharging our borewell. Hence, this being used to receive my water and help in recharging the subsurface of my soil. I have created a natural flow, the exit path for the excess water to flow like that. It takes that exit path through that and leaves my farm on the southeast end, that side. So, when you do your landscaping, rainwater harvesting, farm pond management, farm pond designs, you should consider all these things. A, welcome the rain, that is inflow of the rainwater into your farm pond. B, storage of rainwater onto a specified area for subsoil recharging / agricultural purposes. Also, if you use pond lining, as a natural farmer, we do not use pond liner or we do not want to use plastic. Then you have to also create, it is important, you should create also the exit path. The excess rainwater has to leave your farm and go out through its natural flow. So, when you look at your new land and you look at your landscaping, identify these things. From where the water comes down, what is the ideal location to store that water, and how I can create an exit path without disturbing my other plantation or without affecting my fellow neighbor on the downstream. This is very important while planning landscaping.